Hello everyone, welcome to 12 AM Coding. So today we will be discussing about a new problem in our linked list series, which is rotate the linked list in clockwise direction by keynotes. So first of all, let's understand what this problem means and then we will be moving to the solution. So in this question, if you see there are three important points to note. First one is we need to rotate and we need to rotate in the clockwise direction and we need to rotate by keynotes actually. So first of all, we need to rotate this linked list in the clockwise direction, which means into this particular direction. So this is the clockwise direction. And if you want to move anti-clockwise, then this will be the direction anti-clockwise. In this question, we'll be considering this direction. So you need to rotate this linked list into this particular direction clockwise. And by k nodes, you need to rotate. So for example, if we are having k equals to 1, then your new linked list will become, if you rotate this, then this particular kth one node we just want to rotate it, so 95, then 95 will be pointing to 12, then 18, then 45, then 82. Okay, simple thing. So we just rotated this linked list. Let's say we need to rotate it by 2, then again we need to rotate from here, which means this 82, 95 will be remaining same. Now 95 will be pointing to 12, then 18, then this will be pointing to 45, then this 45 will be pointing to null, and here also 82 will be pointing to null in the case of k equals to 2. So if we see this particular question, then we can notice one thing, that we want to rotate the number of nodes, so those nodes we are getting to the front, and the previous of that particular number of nodes we are pointing to the end. Actually we are marking it as end. So let's understand this particular thing in a little bit more deeper way. So as I told, right, for example, we are having one linked list 12, then 12 is pointing to, let's say, 18, then 42, then 82, then 95. Okay, and this particular is pointing to null at the end. Okay, now let's say we want to rotate this particular linked list by k equals to 2. So what we can do in this particular case, that currently we are having 1 2 3 4 5 nodes in our linked list. So we need to rotate it by 2. So what we can do, 5 minus 2 equals to 3 we can do. Okay. In the simple way, what we can do is this particular linked list, we can directly point it to beginning. Okay, whatever our current beginning is. And this particular node we can point to the null. So in that case, if you will shift these particular nodes, then what it will become? 82, 95. Then this particular linked list will be here, then 12, then same way 18, then 42 will be pointing to the null node now. Okay, so you are able to rotate the linked list by these particular points. Now in this question, if you see that what intuition we can develop is that we just need to traverse till this particular node. Okay, till this particular position. So if somehow we come to this particular node, which means 1 2 3 nodes we come, then after that this particular node, let's say we are keeping the track of this node as a previous node of whatever k nodes we are having. So let's say this will become previous. Okay, and once this became previous, then what you can do, this previous you can point to the null, and whatever the linked list we are remaining, okay, after this particular previous node, we can just traverse this linked list till the end, and this end we can directly point to the front of this particular linked list. So this way you will be able to point your linked list to the you will be able to rotate your linked list to the clockwise direction. Okay, so one thing we can do, let me write few points here so that we can better understand it. First of all, you need to reach till the previous node, previous of k nodes. So whatever nodes we are having, so we need to reach to the previous node of this one. Then simply what you can do, this previous dot next, you can point to null. Okay, so this link will be broken. And once this link is break, then what you can do, whatever remaining, the second linked list, the second linked list you can bring to front. Okay, and let's say this particular linked list is second linked list. Now second linked list and will be pointing to the head now. Okay, so I hope this particular thing is making sense. So let us move to the code. And before moving to the code, I want to tell you one more important thing, which is, let's say we are having 5 nodes in our linked list. So if you want to rotate by 0 nodes, then it means you don't want to rotate. And for example, if you rotate the by 5 nodes also, let's say size is 5, okay, and your k is also equals to 5, then in that case also you need to rotate it 5 times, so it will be same linked list only. Okay, so this is the thing. And let's say if size equals to 10 also, then 2 times you need to rotate 5 in the, it's the same case, right? So you don't need to rotate the linked list. So one thing we can observe here is, if your this particular linked list size is 0 or equals to size or multiple of size, right, multiple of 2s it will be, then you don't want to rotate it. For example, if your k equals to 7, okay, and size equals to 5, in that case also, first of all, if you want to rotate it, then you will be rotating it by 5 position. So you will get the same linked list right after 5 position, because we have discussed here, after 5 you need to rotate 2 more times. So in the end, your linked list you need to rotate it by 2 times only, right? So what I'm saying, let's say this particular linked list we are having, its size is 5. If you rotate it by 5, this will be same linked list. Okay, if you want to rotate it by 7, then first you need to rotate by 5, which will be same linked list, then simply you can rotate by 2, so it's the same as a 2. Okay, so what you can do is that whatever size you are having or whatever k you have given, okay, if you will calculate the mod of this particular k, if you will calculate the remainder with the k, then you can rotate to that particular position. So let's say if our k is 7 and we want to, and size is 5, then our remainder will be 2. Okay, so you can rotate it by 2 positions only, and then your work will be done. If let's say it is a 8k, then modulus 5, then it will be 3. So you can rotate it by 3 only. So this case also we will be handling. So let us jump to the code, okay, and let's see how it goes. So what I can do in my this particular linked list class, simply I am going to create one function which will be returning me the node, which will be the head of the linked list, so that I can have the linked list. If you are not aware about it, you can go and watch the earlier tutorials. We have covered these things into very detail. So let's say we will be creating a function rotate linked list clockwise direction. Okay, and this, in this we will be taking a k, how many nodes you want to rotate, and then we'll be taking the node also. Okay, this will be our head actually in the beginning. So simple case that if your node equals to null, okay, or your k is less than 0, which means someone has provided minus in the minus value, then we don't want to do anything, we can just return it as node also. So k equals to 0 also we can return it, but I'll be telling you one good way to do that. So first of all, what we need to do, we need to get the size of the linked list, because we need to handle this particular case also. Okay, if someone has provided the size, the k node which is greater than the size, then you need to take the remainder. So first of all, we need to get the size. So we are having get size of linked list function already in this particular class. Simply what we are doing in this, we are just traversing the linked list till the end where we reach the null, and we are counting the number of values in the linked list. Okay, so you can watch the earlier tutorial for this one, and we can pass our head in this particular function. Okay, and I forgot equals to, so we got the size. Now what your k will be, k will be k modulus size actually, which means you are taking the remainder of k and size so that you can rotate it. Now after it, let's say your k equals to 10, then 10 divided by 5 will be your 0 only. Okay, so if k equals to 0, okay, in that case you can return the same linked list, because if size equals to 5 and you need to rotate by 10, at the end it will be same. If you need to rotate by 15, at the end it will be same only, so you can just return the node here. Else what you need to do, what I have told, the main intuition is we need to reach till this particular position, the previous position till of the k nodes. Okay, so what we can do, we can just mark this as a previous, and this previous in the beginning will be the head actually. So we need to traverse from here, then we need to reach till here. Okay, and we can just take the integer I equals to 1 also for keeping the track, and while your I less than size minus k. Okay, so whatever size we are having 5, and k we are having, k will be a reminder at the end. So if 2 we are having, then what you can do, 5 minus 2 equals to 3. Okay, so you need to traverse till 3 actually. So till size minus k we need to traverse, and we can just increase our previous with the next actually. Previous equals to previous dot next, and I plus plus we can do. Okay, until I reach to the size minus k, till we reach, if k equals to 2, till we reach at this particular location. Okay, now once this has happened, then what you can do after this particular thing, as I told, we need to develop this particular connection. Okay, and we need to break this particular connection, that the previous dot next we can mark it as null, and now we will get the this particular new linked list. So what we can do currently, we can keep a temporary node, and this temporary node will be storing this particular linked list after this previous. So what we can do, previous dot next you can do. Okay, and then you can keep the head also track, because our head will be changing. Okay, our head will be temp now, right? Our head will be this particular, because at the end this 95 will be pointing to the this particular earlier head, and 82 will be becoming our new head, which is the previous dot next. So our head equals to temp now. Okay, and after that simply you can mark previous dot next, okay, equals to null, you can make it. And as soon as you make to the null, then we can this particular connection is broken. Now we just need to traverse this linked list till the end. Okay, so while your temp dot next not equals to null, you need to move temp equals to temp dot next, you need to do. Okay, and at the end what you can do, temp, so this particular temp you will be reaching at the end, right? So this temp you need to mark to the older head, which is our node actually, whatever is coming. So temp dot next equals to node now, and you can return the head, because we already kept the track of head. Okay, so this will be our head. So let me run this particular function and see. So currently our linked list is this particular linked list, 14, 18, 16, 87 and 98. So we want to rotate it. So we are already having one class, linked list operation. In this particular class only we have created this method, which is rotate linked list clockwise. Okay, so I'll be calling this particular method, and our head, it will be returning us the new head. Then operations dot rotate linked list clockwise, and let's say I want to rotate with two nodes. Okay, then we can pass our head, current linked list we can pass, so it will rotate it. And then you can print, or we are already having the print function, so we'll be printing this. Okay, print linked list whatever head we have. So let me run it quickly and show you. So if you see, we just rotated it with two nodes. So 87, 98 came in the beginning, and then 98 next will be pointing to the 14, 18 and 16. So let me debug also and show you. So if we debug this particular code, in the beginning, if you see, our node will be having the entire linked list, 14, 18, 16, 87, 98, and 98 is pointing to the null. So the first case, it's not equals to null, so we came here, then we got the size. So our size is 5 nodes we are having. Then you calculated the remainder, so k will be your 2 only, because 2 modulus 5 equals to 2 only. Then if k equals to 0, it's not 0, so we came here. Now your previous has become, in the beginning it is a 14th first node. Okay, this particular node. Okay, and after that integer you are keeping, and you are running till you reach to the third position. So if you see, now your previous will be 16 actually. If you see, your previous is 16. So you are previous dot next, now your temporary will become 87, because from here we need to point to the that particular head, right? So this will be our new head. So our new head has become temp, and previous dot next you are pointing to the null now. Okay, so this 16 is pointing to the null, and whatever temporary node you kept, this 87 and 98, now you will be traversing this. If let's say that there are three nodes, then it will be having three nodes, you will be traversing till the end. Okay, so we can traverse it, and here you reach to the temp. Okay, temp is your 98. Now 98 you will be pointing to the beginning, and this node is the beginning. Okay, this node is the 14th. So you traversed it, this link you already broken, because 16 is 16, if you see, it is already pointing to the null. Okay, the 16 is pointing to the null. Now your 87 and 98, you just traversed it, and now 98 dot next you are pointing to the head. So your temp will be 98, then 14 it is having, okay, and then you are returning our head simply. Okay, so your head is 87 already because you keep track of it. And then if you see it, then this will be our new linked list: 87, 98, 14, 18, then 16, same way. Okay, and you printed the linked list: 87, 98, 14, 18, 16. We we reversed by two nodes. Let's say you want to reverse by three, then it will be three nodes, right? 16 came into the beginning and 14, 18 went. Now let's take the example of 7 also. Okay, so let's debug this particular code. Oh, it ran it, but fine, let me debug it again. So if you see, we will be counting here also k again. So here let me show you. So in this case our k again became 2 because 7 modulus size equals to 7 modulus 5 equals to 2 only. So if you see, we just rotated with the two nodes. And let's say if you have given the size whatever linked list we are having 5, then this will not be rotated. If it's 10 also, it will not be rotated. Okay, so it's the same thing. So yeah, guys, this is it for this particular video. If you like the video, then definitely share with your friends and keep learning, keep moving on. So yeah, that's it for this tutorial. See you in the next tutorial. Thank you.